about paired data way back when we were talking about experiment design. So paired data is like when you have twins and you give one twin one treatment and you give another twin the other treatment, maybe a placebo versus a drug or something like that. Anybody remember another way to use paired data that wasn't twins? Yeah, Shay, what do you think?
If it's on like the same patient?
Yeah, exactly. One patient gets both treatments. Yeah. Anything else? Yeah, Austin.
Cars and gas. Like
Cars.
the same car, like.
But two different gases.
Yeah.
So that's kind of the same thing where it's one. Yeah, subject is specifically a person though. One, what's the term? Individual, there you go. Individual with two different treatments. So that's kind of the same. The other thing would be, so we've got, here, let me just write these down. Paired. The thing that I want you to think of is twins, because that's sort of like the ideal situation. But also subjects that are closely matched. Or one person gets both treatments. Or car. Or whatever. I think you're going to find that this is going to come up more often than some of the other stuff. Versus what we've been talking about the whole chapter, two sample. Two groups with separate treatments are compared after some treatment time. So what is that? All of chapter 10 so far. That's it for notes. Yeah, it's a good day for notes, right? That's really it. I want to do a problem though with you. A couple of them actually. Let's see, let me get to the right page here. One of them we're just going to talk through. On page 688, number 91, it's on the board to do, but we'll consider it done when we talk through it. So we want to decide, is this paired data or is it two sample? So A here for 91 says, to test the wear characteristics of two tire brands A and B, each of 50 cars of the same make and model is randomly assigned brand A tires or brand B tires. Is that two sample or is that paired? Some cars get brand A, some cars get brand B. That's two sample. An example of where this could be a paired is if, let's say, I put brand A on the front and brand B on the back of the same car. and maybe I randomly assign whether it gets, which one goes to the front and which one goes to the back for some sample of cars. That would be paired, but this is definitely two sample. To test the effects of background music on productivity, factory workers are observed for 1 month. Each subject works without music. For another month, the subject works while listening to music on an MP3 player. The month in which each subject listens to music is determined by a coin toss. That's paired. That's definitely paired. Each person gets the month with and without the music. So, paired. And the last one. How do young adults look back on adolescent romance? Investigators interviewed a random sample of 40 couples in their mid-20s. The male and female partners were interviewed separately. Each was asked about his or her current relationship and also about a romantic relationship that lasted at least 2 months. Where are we at there? When they were aged 15 or 16. One response variable was a measure on a numerical scale of how much the attractiveness of the adolescent partner mattered. You want to find out how much men and women differ on this measure. That's what I said. The book disagrees with us. Yeah, I know. I near as I can tell, is because it's a couple. I think that's the key here, is that you've got a couple. I think the asking about the relationship from when they were young is sort of a distractor, you might say. But I would, if it were me, I would say it's 2 sample, and according to the book, I'd get it wrong. But they're saying this is paired. And I think it's mainly because we're dealing with the couple as being, you're A and B, male and female, are both getting a treatment. But the treatment's kind of the same. I don't know. Sometimes I wish there was somebody I could ask other than the book that just, I think, says paired, I believe. Let me consult that real quick. Let's see, 91. Yeah, it just says paired t-test. It says the data were collected from the male and female partners in 40 couples. So I would tend to wonder if maybe they misread that one, but go with your gut. Go with your gut. Those of you taking the AP test, trust your gut on that stuff, right? Okay? Don't let a problem like that throw you off like it does me. Oh wait, I still want that. So, yeah, to me, I would say 2. Anyway, let's look at 93 though. It says have a ball. They're comparing the ability to throw a baseball versus a softball, and they think that the baseball will fly farther than the softball. So each person gets to throw both. So that's definitely paired. And they're randomly choosing which ball gets thrown first for each person. And what we want to do, and I'm going to have to do this with you because I've cleared my calculator, is we want to put in the baseball and softball numbers into our calculators, and it continues on the next page, or on the top of the same page. Let's see. Okay. I think I've got all my numbers in. Hopefully they're correct. I'm going to double check it. Okay, so here's what I did. I actually put in 3 sets. Don't be too impressed, I already had L3 in. And then I did an L1 minus L2 to see if it matched what the book showed, and it did. So I'm pretty sure that I've got all my data in correctly. So here's what we want to do. First, we're not going to take the problem directly as it says, but A, explain why this is paired data. Well, that seems pretty simple to me. This is 93. So we've got baseball versus soft. It's paired data because each subject throws both balls. Okay. And it says a box plot of the differences shown. Explain how the graph gives some evidence that students like these can throw a baseball farther than a softball. So here's our graph right here. And the evidence that I see is that it looks to me like at least 3/4 and a little bit more can throw the baseball faster than the softball, because it's baseball minus softball, which gives us a positive value. So I would simply say that more than 3/4 or more than 75% of the subjects were able to throw the baseball farther. That's evidence. I mean, is it significant? I don't know. But is there a problem with that graph? Yeah, what's the problem that you see? Yeah, we got an outlier, right? So that's an issue. And that's an issue we're going to deal with. So C asks us, state the appropriate hypothesis for performing a test about the true mean difference. Be sure to define any parameters you use. Okay. So the null hypothesis, this is the way I would write it, that the mu of the baseball equals the average of the softball. The book would probably have you do it this way. Somebody in the last class asked, well, do you think the AP will accept this first version? I think they will. Do I know for sure? No. If you really want to make sure your life is solid for that test, go with what the book says, because I'm not going to pretend to know more than the writer. The alternative, though, they think the baseball's going farther than the softball. Okay. Maybe I should just change my way of doing things. I don't know. So what's mu of B? That's the average baseball throw length. Mu of S so I've defined my parameters. Explain why the normal large sample condition is not met in this case. We've already said that. B, outlier. Exactly, we have an outlier. And at this point, the problem set goes off into a sort of an activity that we're not going to do today. But I do want to finish this problem up. What if, and I want to look at it from two ways to see if there's a shortcut. See if we can discover a shortcut. Because we have two samples, and we're taking the difference of the samples. What would you do if you were the researcher and you had this one outlier? So maybe this person tried to make sure that the baseballs were good. And he threw the baseball really hard, threw it really well. And then when he got to the softball, he or she did something like this. Right? Okay. Throwing off the wrong foot or something silly like that. I don't know. So what would you do with that person's data?
Probably get rid of it.
I think I'd get rid of it too. Yeah, I think I'd ditch it. So let's see if we can find the outlier and ditch it. I think the outlier is pretty evident in the data. Yeah. Number two, yeah, the 32 foot difference, or yard difference in this case. So let's get rid of these. So to do this, I'm going to get rid of the 98. I'm just going to hit, or the 90, I'm going to hit delete. I get rid of the 58, hit delete. And then these two. So, yeah, I'll get rid of number two. Now, let's assume all the conditions are met on this. I've got two samples, so it's going to be a two-samp Z test to see if there's a significant difference between the two. Right. So let's do that. Let's try that two-samp Z test. I'm sorry, I said Z t-test. We don't have sigmas. So data. Let's see, I've got an L1 and I've got an L4 or L2. Let's see, we think L1 is bigger than L2, L1 being the baseball throw. So I think I'm good there. Pooled is no, and calculate. So I've got a p-value of about almost 12%. Would that be significant? Is there a significant difference looking at it that way? No, it's larger than any reasonable alpha, right? So we would fail to reject after tossing that outlier. We would fail to reject. Now I'm just curious here. We have the difference. Maybe you didn't put it in the calculator, but I did. I have the difference of the two. I wonder if I took that difference and just did a t-test, if I would get the same value. Let's check it. So if I go to t-test and I use my L3, which is the difference that's already been calculated, into 1, and we've got that, that we're greater than there. Null hypothesis would be 0. Now I get a very different p-value. That p-value is quite large. Oh wait, no, quite small, right? So is there a shortcut to putting in just the difference as given and using a t-test versus the two-sample t-test with both sets of data? And the answer to that's no. Clearly there's not a shortcut there. Okay? So anyway, for any of you that are looking for a shortcut, that doesn't exist. So we've got to put the data in for both.